Hello everyone and Dia Yves Gachtina. Welcome to Dreamspace Live here celebrating Science Week. And we're delighted here in Dreamspace to be celebrating this with amazing collaborators in CERN Open Lab. So my name's Amanda, I'm here from the Dreamspace team and I'm joined by Rua from CERN. So say hello everyone, Rua.
Hi, so my name's Rua and I'm a science communicator and researcher from CERN.
So welcome. And we're also going to be joined by Rua's colleague, Mariana, later on in the live stream. So we're really lucky not to have one, but two amazing CERN researchers here with us today in Dreamspace Live. Really hope everyone's been enjoying Science Week. It's been going on for a little while now. So I'm sure lots of fun things have been happening across your school communities across the whole week. Do let us know about those in the Q&A. And also say hello to us in the Q&A. Let us know your school name, where you're joining from. And we will do our best. We have a lot of people joining today, but we will do our best to give you a few shout outs across the live stream as we go as well. So I think we'll jump in, Rua. We're good to go?
Yeah, we're ready to go.
Yeah, so let's see. Let's have a little talk about Science Week. And I suppose before we even talk about Science Week, Rua, I think we should just talk about what is science.
Yeah, great question. Okay, so science is the study of everything around us in the world, but we study it in a particular way. So we come up with ideas about what might happen. We call them theories. And then we use observations and experiments to try and see whether our theories are correct.
Brilliant. And I actually was a science teacher before I joined Dreamspace, so I'm extra excited about this. I also was obsessed with CERN. So when we heard we were working with you, I was like, yes, this is so exciting for me. And obviously in CERN, you do a lot of this type of thing, but also in schools across the country, primary schools, post-primary school settings, people are doing this as well.
Definitely. And like you, I was a science teacher as well before I went to CERN. So
yeah. The passion remains.
The passion is there.
Yeah, exactly. Yeah. And then obviously, folks, science really does matter for us in our everyday lives. It's how we gather information. It's how we then make decisions based on that information. Helps us create new technologies. It helps us solve problems. It helps us make really informed decisions about our world and everything that's happening around us. So it's a really, really important part. And that's why Science Week is really important too. So Rua, you have been finding lots out about Science Week. So can you tell everyone what you know?
So Science Week is this really great week that is going on where people can celebrate everything to do with science. And lots of schools and universities and libraries and places within the communities put on loads of events that are to do with science, and they're really fun and they make science more accessible and enjoyable, so you can see how science is relevant to your life.
Yeah, brilliant. And as I said, hopefully people have been really enjoying Science Week across the entire week so far. I know we've had lots of fun in Dreamspace as well with Science Week so far. And this year's theme of Science Week is then, today and tomorrow. And so I think this is actually really applicable to obviously science, but also, Rua, to what you folks do in CERN as well.
Yeah, definitely, because CERN is a huge organisation, but we have to look back to the past and see where the science has come from, and also try and create the science of the future. So it's really like looking back and forwards at the same time.
Yeah, exactly. And there's so much to learn from what's gone before us.
Absolutely.
But there's still so much more to discover.
So much more, yeah.
So that's the really, really exciting thing as well. And obviously this, I suppose this collaboration came about at a really good time because Ireland literally just recently was announced as a new associate member state of CERN.
Yeah.
I'm sure you were excited about that. I know you've links to here.
So excited, yeah. And so they just joined in October. So really it's very new, like just a month ago.
Yeah.
So it's really exciting now.
Brilliant. And to celebrate that and to mark that, we actually have a video from our Minister James Lawless, who actually oversees the work that we will be doing with CERN as part of his role. And so we have a little message from him to kick us off, and then we'll get back and we'll have some questions for Rua. But you can get your questions in as well in advance if you already are brimming with questions about CERN and about the work. We might cover some of them in our little chat in a few minutes, but you can actually start getting them in as well to the Q&A. But first of all, let's hear from Minister Lawless.
Díagh Mutori, Mick agus Finachton na Tauki. Hello teachers, students and discoverers of the future. Today is a special day. You're about to explore one of the most exciting places in the world of science, CERN. CERN is where scientists from all over the world come together to study the tiniest building blocks of the universe. Particles so small you can't see them, but they help explain everything around us. Just under a month ago, Ireland became an associate member of CERN. As Minister, I want to tell you just how proud and excited I am about this. It's a huge moment for Ireland. A door has opened to one of the most advanced scientific communities in the world. This means Irish students, teachers, researchers and businesses can now work with CERN in new and exciting ways. And that includes you. Whether you dream of being a physicist, an engineer, a computer coder, or something we haven't even thought of yet, CERN is now a place where your future could unfold. Let me tell you a short story. In 1843, an Irish scientist named John Tyndall was born in County Carlow. He became one of the first people to explain why the sky is blue, a discovery that helped to shape modern physics. He didn't have a particle accelerator or a supercomputer, but he did have curiosity, courage, and a love of learning. Today, you have tools and opportunities that John Tyndall could only dream of. And now, with Ireland's membership of CERN, you have access to one of the greatest scientific playgrounds in the world. If today's workshop sparks something in you, a question, a curiosity, an idea, hold on to it. That spark could be the beginning of your journey into science. As Minister for Further and Higher Education, Research, Innovation and Science, my job is to open those doors for you. And today the door to CERN is truly open. Thank you to CERN and to Microsoft Dreamspace for making this event possible and for nurturing the scientific curiosity of Ireland's young minds. Greibh maithagh agus tásúla gom go mbainigh sibh taitneamh as an lá. Thank you, and I hope you enjoy the day.
Hopefully you get the idea there that Minister Lawless is also really excited about this. So that's the work that his department was doing. As you said, like, people may not know a lot about it, but now that we are an associate member state, there's actually a chance for Ireland and young people joining us today and whoever to kind of nearly engage more. Like, what does that mean, Rua, joining this?
Yeah, exactly. So now it means that people from Ireland can go to work at CERN, or they can go as students to do student programs there. Teachers from Ireland can go to teacher programs there. So there's a lot of opportunity now for Irish people to go and get involved in the science of CERN, which is a really exciting place to be. And
perfect, yeah. And so I suppose, Rua, that brings us on. We're going to have a little chat. And again, get your questions and answers in, or questions in. We'll get the answers back to you at some stage as we go. But I suppose that brings us to, like, where is CERN? I think you've shared a lovely photo here. So maybe you can explain what this is and where it is.
Yeah, so what you can see here in this picture is that, well, CERN is on the border actually between two countries. So it's on the border between Switzerland and France, and it crosses over the border. And in the background you can see the Alps. So it's really close to the Alps, the mountains. We can see the snow in the background.
Oh, lovely.
And this big red circle is it's where the biggest machine in the world is, except that it's 100 meters underground. So you can't see it like this. This is just showing where it would be if it was above ground.
Oh yeah, this is it, isn't it? I think this is the big machine.
Yeah, so it's the largest machine in the world. It's deep underground inside a tunnel, and it's called the Large Hadron Collider, or we call it the LHC for short.
LHC.
Yeah.
I think we'll use that a few times today. So remember, when we say LHC, it means Large Hadron Collider.
Yeah. And so it's in this huge tunnel. It's 27 kilometers long, so it's a really big circumference of the circle. And this machine is like the greatest technology, basically, that there is in the world.
Yeah. Unbelievable. And it's so long that you actually have your engineers having to, like, get on bikes to, like, go around.
Absolutely,
is that right?
Yeah. So the scientists and engineers need to cycle around it to try and get from one part to the next to fix it, because it's just such a big space. They can't walk it. It would take too long.
I think that's so. I love the way they have their helmets on. Very important.
Absolutely.
Safety first. And then when we're looking at this, I suppose this gives us the kind of something that's part of the tunnel, like the detectors, isn't it?
Yes. So the whole tube that you saw before is called the accelerator, and we're trying to accelerate particles. So we put in very small particles called protons, and we accelerate them to faster and faster speeds by giving them more and more and more energy.
Okay.
Until they get to almost the speed of light, and that's the fastest that anything can travel at. So really, really fast. Yeah.
Yeah.
And we give them so much energy, they're going to almost the speed, and they go in two directions, and then at certain points they collide, and this happens inside these big detectors. So this is one of the detectors, and right in the center of it they will collide.
So these protons, maybe young people join us, they might have heard the word proton before, they may not have, but a proton is just a part of an atom, isn't that correct?
Yeah, absolutely. So it's a very small part inside an atom, which is in what's called the nucleus of the atom, so the very center part of the atom. And if you're not sure about atoms, well, basically everything around us, so tables and chairs and our bodies and even the air we breathe, are made up of these very small particles. So basically, if you zoomed into, say, a piece of hair, you would get down to all the cells, and then you get down to the chemicals that make up those cells, and then the atoms. And very deep inside, you get to the particles that make the atoms. They make up everything around us.
Yeah, that's mind blowing to me because I'm like, cells are even invisible a lot to our human eye as individuals. So then to think you have to go deeper to get to an atom, and then deeper again to get to these protons that you're flying around in this machine.
Absolutely.
So that's when science to me is like, you know, it's insane.
And they're so tiny that we can't see them. We could never see them with our eyes, but we also couldn't see them even with the greatest like magnifying technology. So we just need to find ways to detect that they're there, but without being able to ever see them.
Yeah.
And that's what these detectors do. So you can see in this detector that there are, well, it's very colourful. That's
that's the first thing I thought when I saw it. I was like, oh, and I see lots of wires and lots of things here.
Lots of wires, lots of technology, lots of different types of material and stuff. And that's because the particles will interact with different materials in different ways.
Okay.
And we can tell from those different interactions what kind of particle has passed through without being able to see it.
Okay, very cool.
And this creates a lot of signals.
Yeah.
Sorry if I just explain this.
Go for it. Yeah.
This creates loads of signals within our machine. And we have all these signals, lots and lots of data being created. But we have too much data for us to be able to actually store. So we need to tell our computers in advance what kind of data will be interesting to store and which kind of data will be not very interesting to store.
Yeah.
So we come up with a theory, the scientists come up with a theory, and they decide, oh, these kind of things might be interesting, these kind of things might not, and they tell the computer what kind of data to store so that they can know that.
Yeah, so so basically, if we go back, they're these particles, these protons they're coming in different directions.
Yeah.
They're coming in. They might collide.
Yeah.
They
or
may
they
not
might pass through each other. Yeah.
Yes.
And the ones that pass through just go around the loop and do the same again. So they might collide the next time. So they keep going round and round.
Sounds like a fun kind of roller coaster if it was like a person doing it. Yeah. So they might collide. They may not. And if they do collide, what you are looking for is there anything new out of that collision, basically?
Exactly. So we're trying to understand a bit more about the particles themselves and how they act, and also trying to create completely new particles that maybe we've never seen before. So we're trying to really create new stuff. And
oh my
see
God.
if we can do that.
Yeah. And is that the ultimate aim, you know, just to understand for everyone watching, like, why are CERN doing this? Why are we, you know, why are we all, people like you, amazing brains and minds, looking at this in detail?
Yeah, we're trying to do, so we're trying to answer some really big questions. And those are, how did the universe begin? So that's a huge question.
Yeah,
we have a theory called the Big Bang.
Yeah.
But we don't really know what happened in the very first instance of the universe.
Okay.
And we're trying to also find out what everything's made of. So what are we all made of? And what will happen to the universe in the end? So there are these three really big questions that we're trying to answer by colliding these particles together.
Yeah, and it kind of goes back to the theme earlier because it's looking at kind of what's gone before us, but also looking ahead to what is to come.
Exactly, yeah.
Okay, brilliant. Thank you so much, Rua. And again, if anyone watching has more questions and you want to understand more about what Rua has mentioned or anything, we'll either maybe get to them at the very end of our event if we have time. But if we don't have time, Rua will actually be joining the Q&A shortly. So you might see some questions come in there and Rua will be able to respond in the text in there as well.
Yeah.
So we'll try and make sure that if there's any brimming questions out there, we can do that too. But for now, we are going to ask you in your classrooms, based on everything you've just heard about CERN and even based on those images, we're obviously shortly going to start looking at the role technology plays within CERN. And it does play a big role, as you mentioned already.
Role,
yeah. So in terms of the data you talked about, the computers,
the materials that we put in these detectors to detect the particles and things.
Exactly. So maybe think about what specifically do you think people working in CERN are using their technology to do alongside all of that. And we're going to ask you to do this in a think, pair, share way, the way you've probably done this before in your schools. But just in case you haven't, we want you just to take a minute in your classrooms to just think about this question. Think back maybe to something Rua has said. Think back to maybe some of the images we just had. When you have that done, after a minute, work with the person beside you, talk about it, maybe jot down some ideas if you have mini whiteboards, pens, paper, something like that. And then ultimately, with the help of your teacher, let us know in the Q&A what you're saying in your classroom so that we can maybe discuss that as we move into our next activity. So we're going to give you a couple of minutes to do that and then we'll be back. Okay, folks, so welcome back. Some really lovely questions coming in there in the Q&A. And you may have noticed Rua has departed. As I said, she's gone actually to have a look at maybe any questions that are coming in there, so she can help start answering them. But we have been joined by Mariana. So you're welcome, Mariana. Do you want to introduce yourself?
So hello everyone, I'm Mariana and I'm a science communicator for CERN openlab. That is a mechanism of CERN that works with companies and research institutes to advance computing for scientific applications, especially at CERN, and to help with the research that is being done there.
Very exciting.
Yeah.
Good stuff. And so, Mariana, we've been working with you on how do we help students understand this side, like the computing side, because as you said, there's a lot of information. We talked earlier with Rua about all the different data. So we're going to do some fun activities now, and you're going to get to do them in your classroom. We're going to start with one that's unplugged, and then we're going to move on to one plugged. So we'll be using our laptop devices to do that one too. But for this activity, our first activity is called data detectives. And what you're going to do is you're going to be scientists, you're going to be researchers, you're going to apply those kind of ways of thinking that we have to do when we are doing science experiments. And with your experiment, you're going to observe what happens, and you're actually going to collect and analyze some of the data that results from that experiment. So you may have noticed in some of the emails we sent, just if possible, and don't worry if you don't have it right now, because we do have a backup plan for you, but if possible, if you had 2 objects in your classroom that you could roll, that would be super. It could be 2 tennis balls, 2 footballs, something like that. And what we're going to do is, we talked earlier with Rua about the way that in the Large Hadron Collider, that when particles are going around, they're moving towards each other. And sometimes they collide and sometimes they miss. And actually, part of what you're tracking is to see, like, obviously you're trying to see how many are colliding, but you're also looking at what happens after that.
Yes.
Isn't that right? So we are going to go through the different steps that you'll have to follow to do this in your classroom. You're ultimately trying to see what is happening. But before you do that, we want you to make a prediction. So in a moment, I'm going to play a video of myself and my colleague Michael from Dreamspace. We actually pre-recorded a video of us doing this very experiment yesterday. So if you don't have 2 objects in your classroom ready to go to test this out yourself as a class, no problem. You can watch along with the video and you can take note of what you're seeing occur and what happened with us. But if you do have the objects, you can just mute that video, you can mute away, and you can do this in your classroom yourselves. We'll give you enough time to get it done. But the first thing everyone in their classrooms we want you to do with some pen, pencil and paper, or a mini whiteboard, whatever you might have at your desk, is you're going to predict out of the 10 attempts we're going to make when we have these 2 objects rolling together, how many times they will collide and how many times they will miss. And then you're going to write down your prediction. So Mariana, I obviously know that what happened, so you don't. So can you predict for me what you think is going to happen?
So I would predict that around 6 times the balls are going to
Okay. So 6 collisions, you think, and
exactly.
therefore 4 misses.
Yeah,
So
exactly.
10. Okay, you write that down there now. We can come back to it. We can come back to it afterwards. Okay. So in your classrooms, again, you can make your predictions around how many times out of 10 attempts, how many times was there a collision, how many times was there a miss. And then what you're going to do is go ahead and conduct that experiment. So again, if you have this equipment in your classrooms, you can do this yourselves. Maybe 2 students can be selected to stand opposite each other at a certain distance, and you can decide, and then roll the object towards each other. And then as a class, you're going to keep count of how many hits happened or collisions and how many misses happened. So record those results down. In a moment, I'll play the video for you if you don't have those objects, and you can use our experiment as yours. Okay? After that's done, really importantly, we don't just do these experiments and go, well, that's done, and then walk away. It's really important, isn't it, Mariana, that we analyze the results. So we're looking for information. What kind of analysis do you think you'd be doing in CERN with these types of things?
I would say, for example, if we were using this as an example, for example, the distance that we are using to collide the 2 balls, or what happens after. And for example, if we have more than 2 balls, what is happening?
Okay, I love that one. Yeah. So you can look at the results we had. So there's going to be very easy results, I would say, where you know there was, if you predict is right, there was 6 hits and 4 misses. That's easy. But maybe there's other things that can be analyzed. Like you said, if we introduce a new tennis ball, for example, in our experiment, or if we lengthen the distance or decrease the distance.
Yeah.
So maybe have a little discussion about that in the class. And that discussion is really important. And as scientists, It's really important that we do have those discussions with each other. And then ultimately, what all scientists do is communicate back the results. It's really important that we share this, so you can share back in the Q&A how your classrooms got on with this. Did you have the right predictions? What went wrong? What you think you would change if you were to do the experiment again? These types of things. And that's all ways that scientists have to think as well. And so really important, isn't it, to communicate back? You do this all the time in CERN. You're always letting people know what's happening. Isn't that right?
Exactly. It's always important to show what we are doing, why we are doing it, and what are the results, because what happens at CERN might be also applicable outside of CERN. So.
Yeah, perfect. So I'm going to leave this up. So you're going to make your prediction, okay, whether you're doing it in the classroom or whether you're watching our video. And for the next step, conduct an experiment. You can go ahead now and you can start doing that in your classroom, and you don't need to worry about us on the screen. But if you don't have 2 objects to roll, we're going to play the video in a moment and you can use that. So maybe you can make sure you've noted down already, how am I going to monitor how many hits and how am I going to monitor how many misses? And then when the video is over, I'll put this slide back up again so that you can analyze those results and let us know in the Q&A. So we're going to give everyone a good 10 minutes probably to get this done, just under maybe 10 minutes. So lots of time to make sure you do it right. Lots of time to really think about ways you might redo the experiment, change the experiment, and let us know in the Q&A then how you're getting on. But until then, enjoy this video of myself and Michael. Let's see how accurate Mariana's prediction has been. Mariana, I'm afraid your prediction was not exactly
way off.
Yeah, it was a little bit off. Yeah. We don't know why. That's just what happens, isn't it? I suppose
exactly.
when you're doing these things in the LHC as well, you don't actually know how many are going to collide or miss.
Exactly.
In our case, we had 3 collisions, so it was a little bit different, and we had 7 misses. So look, that's the way it is. So what you can do in your classrooms now, if you're based on our video, you might be doing your own experiment, and that's brilliant. But if not, if you're based on our video, you can go ahead now and start thinking about what you saw there and analyze the results. Was there trends? Did you notice the way maybe what was happening if there was a collision? Is there other things you could do to enhance or redo that experiment? And then, as I said, let us know in the Q&A. We're going to give everyone a good 5 minutes more to do this, and then we'll have a little chat about how you get on. Good luck. Okay, folks, welcome back. And it's really lovely to see all those findings coming in, isn't it, Mariana? So you spotted a few that you liked there where people were given different interesting insights. So do you want to maybe call out a few that you liked there that came in there to the Q&A?
Yeah, some said that the 2 objects must be perfectly aligned.
Oh,
the
okay.
rollers must be beside each other.
Okay.
And the throws must be accurate. The surface should be flat. And the speed and timing is key.
Wow, there's so much there to digest, to be honest, because they're all different types of variables, I suppose, in science. So we try and keep maybe everything constant bar one thing we change so that we can, but you can see there's a lot to consider around what do we need to keep constant, the distance, where we're starting, the surface, like that's really interesting. Okay, anything else coming in there?
Yeah, there is a very interesting one where, if we change the size of the balls that we are using, for example, if you use footballs,
Yes.
The number of collisions were bigger than if we use tennis balls.
Yeah, so 2 footballs, did they have the number? They had,
Yeah, 9 collisions with the footballs and 2 collisions with the tennis.
there you go. So that's interesting. I don't feel so bad now. I'll let Michael know not to feel too bad either. Because, yeah, we were using the tennis balls. So that's an interesting one as well. Okay, brilliant. So well done, folks. We hope you enjoyed it. And by doing that, it might seem kind of basic, but that's science. You know, it's literally, you don't know what's going to happen. And to try and understand something, you have to do this experiment. You have to observe. You have to note things down. And then you have to think about it, like you just did there, about maybe the surface, the distance, all those types of things. So really, really great work with that. Well done. And thank you so much for sharing that in the Q&A. So I'm excited, Mariana, because we're going to move on now and we're going to think about when we have like data and information like this, we also need to record it accurately sometimes. And often nowadays, obviously, we use computing to do that. And that's obviously part of your role in CERN and in CERN Open Lab. And so to do that, we are going to have to understand a little bit also about coding. So Mariana, can you let everyone know watching, in case they haven't heard before, they may have, but can you let them know, in your review, what is coding?
So coding is all about giving computers instructions and instructions in a language that they understand what we are requiring from them.
Yeah, exactly. And examples of this obviously be like our apps on our phone are coded, and our video games, there's all instructions in the background telling that video game what to do on certain buttons and things like that. Our websites are all coded. And then in CERN, obviously, you have to use coding as well, don't you?
Yeah.
Yeah. So what we're going to be coding is we are going to be coding the microbit. And again, this might be familiar to people that are joining. I know we have lots of fun with it in Dreamspace. I know, Mariana, you've had lots of fun with microbit as well. And so this is a physical device, and we are able to give that code, give that instructions to get it to do certain things. And we use things like inputs, which is like how this microbit takes information in through its buttons and its sensors and its different movements. And we also can see outputs at the end of that. So we can see lights or we can hear sounds. And so it's a really nice way for us to actually see our code come to life, which you'll be able to see on your screen in a moment as well. The cool thing is there actually is the ability for this thing to collect and store data as well. It can be a data logger. And in our activity in a minute and in our project, that's exactly what we're going to do. We're going to try and think about everything we've heard from Rua earlier and from Mariana around what's happening inside the LHC and how we have to keep some data, but also get rid of other data. And we're going to think about how can we get the microbit to actually show us how something like that could work. So I'm really excited about that. Before we go into it though, we want you to get ready in your classrooms. So this is the point now where you will need your computer devices. One between 2 or 3 is absolutely fine for this. And all you need to do is just go to this website and freeze. You don't need to do anything else, because when we go into the website, there are a couple of steps we'll have to do, and myself and Mariana will bring you through them. So for the moment, all we need to do in our classrooms is get our computers ready, get them onto this website. We'll give everyone 2 minutes to do this. Don't worry, we have lots of time. And then we'll come back and we'll be on the same website as you, and we'll get going into our MakeCode for Microbit activity. So 2 minutes, get ready, and we'll be back soon. Okay, folks, hopefully you're all ready to go. As we move through the rest of the session, by the way, please do use the Q&A to also let us know if you need more time, if you need something repeated again, just give us a shout and we're happy to do that, because obviously we've lots of different classes joining across the country, and so people might be moving at different paces. But we'll try our best to keep it at a nice pace where we're not going too slow or too fast. So just bear with us as we go through that. So let's see, I'm going to go across now to the same website. So hopefully you're still on that landing page, because it will make sense to you when you go there as well. So this should be the site that you're on now, the MakeCode for Microbit website. And as you can see on my screen, I have this purple square and it says new project. So the very first thing I'm going to actually do is click into that. And you can do the same if you want to follow along with me at this point, that's absolutely fine. So you're going to click new project and we're going to give our project a name. Mariana, any ideas?
We can use the particle detectives.
Oh, I like it. Yes. Particle detectives, because that was our initial idea, wasn't it, for this? Yeah, I love it. So particle detectives, because that's what we are trying to do. We're trying to discover, is there any new particles we need to keep because we want to study them more, or is there any we need to get rid of? Yeah, love it. Okay, particle detectives it is. So again, folks, you can write your project name in there as well, and then you can click on create. And when we click create, for me, it's saying welcome and it's going to take me on a tour. I actually don't need to do that. I'm going to bring you on the tour yourself, so you don't need it either. So when this pops up, if it does pop up, sometimes it doesn't, you can click on X so that you just have this lovely, plain, clear screen in front of you. And I'm going to explain how that works now. So when you're in here, really importantly as well, if everyone can just make sure you stay with us as we go, because we are going to be introducing some new categories into our category area in a minute. We're also going to be bringing in some new blocks. So at times, if you are dragging out other things or you get a little bit distracted, you might find yourself a little bit lost or a little bit behind. So please do try your best. I know it's tempting to just keep playing on the screen. Do try your best if we ask you to listen up and look up at the screen with us, to do that so that you don't get lost at any stage. And on our screen now, if I can get you to look up, I'll just quickly explain. We have our microbit here, Mariana, our virtual digital microbit, which helps us simulate our code, which is really good because obviously we want to see, is this working or not? That's very important when we build any technology. In the middle, we have our categories, and you might notice they are color coded. So that's nice because there's going to be a good few different types of blocks, isn't there, Mariana, in our code? So you might be wondering, where did Amanda and Mariana get that block from? Well, have a look at the color and pop across. But obviously as well, if you're completely lost, let us know in the Q&A. Mariana's keeping an eye here, and we can give you a hand with that as well and repeat what we did. And then over here in this area is our coding canvas. So this is where we build out our instructions. This is where we tell our microbit what we want it to do and when we want to do it. Is that okay? Yeah.
Sounds right.
So before we go into this, I'm going to hop back, and if I can get everyone to make sure they're looking at my screen, because it's really important that we kind of set the scene of the activity that we're going to do. Okay, so we are going to be doing our particle detectives activity, as you said. And so just to explain exactly what we want to build with the microbit, maybe Mariana, you can let us know about these smart systems called triggers, because this is going to be really important for what we build now in our code, isn't it?
Yeah, so in a very basic way, as some of you were saying, for example, in the Q&A, where at CERN we use cameras to take photos of the collisions, and like Rua has said before, that we had these images with the particles colliding. So we get a bunch of these pictures that the cameras take per second, and we need smart systems that we call triggers to tell us, oh, you know, this is an interesting collision where a rare particle might be there and it will be interesting for you to study this, or, you know, this is just a normal collision, there is nothing interesting, let's just skip this one. And this is what we will be trying to do today.
Brilliant. So I'm really excited about this. So as Mariana said, we are going to be basically seeing that there's random occurrences. We're not going to know what happens, similar to what you just did with the two tennis balls, for example, or whatever you used in your classroom. You didn't know, are they going to collide? Are they going to miss? So we're going to be looking at what happens with the collisions, which ones we want to keep, okay, which ones are interesting to us, so keep that, and then which ones, we've seen this before, this isn't anything new, it's not interesting to us, so we will skip that. So we are going to get our microbit to actually kind of simulate and mirror this idea to show how computing can actually help us with this. And to do this, you may notice on my screen, there is on this side, there is inputs, variables, and conditionals written in a box. So just to very quickly explain them, if you just stay with me, I know it's tempting to maybe do your coding right now, but just stay with me. Inputs, which you might see our category on MakeCode, are how we take information in. So in the beginning, we're going to make sure that the user can monitor keep, skip using the buttons, aren't we? And so that would be our inputs. Variables is when we get the microbit or a piece of coding program to basically create a variable and we get it to store information. So again, that's important because when things are happening in the background in a computer, you need to be able to monitor them. And variables are a really good way for us to see what's being stored at different times and also to allow that to update if it needs to. And then lastly is our conditionals. So conditionals are if-then statements. It's basically how a computer, any computer program, makes decisions. It's monitoring things, so it's going to be basically saying, if this is the case, keep it, and if it's not the case, skip it. So it's been able to make this decision between keep and skip, which you'll see now in a moment in our program. So I'm going to head back over to MakeCode for Microbit, and hopefully you'll be able to join me in here now. And as I said earlier, do try and stay with us, because there's a few little bits we need to do. And I'm just going to go full screen content for a second, because the very first thing we need to do, which is so important, so make sure you're with me, everyone that's joining on their computer on MakeCode, is in the categories over here, there is a category called extensions. And so I need everybody to click on that. And in here are all these additional things we can add into our MakeCode screen. And very importantly, the very first one you see there, which is very handy for us, is called Data Logger. So please make sure you go into your extensions, click on Data Logger. I'm going to click it now. And you'll notice that when we do that, down here on my screen, I have a new category called Data Logger, which we're going to need to use. So I'm going to give everyone just a minute to make sure they have that done in their classrooms. So just to recap, click Extensions, click on Data Logger from the menu, and when you come back, it should be sitting here. If you're waiting for everyone else, because we're going to give everyone a minute, you can just have a click in here, have a look at what's there. Just don't do anything just yet so that we explain it to you and you don't get too lost. Okay, so another minute or so just to make sure everyone's there, and then we'll keep moving. Okay, folks, hopefully we are all good. We have that data logger menu ready to go for us in this category. So we're going to get going. So let's think back to our activity. We want to be able to actually say log the data to say we want to keep this or we want to skip that. All good? So I'm going to click into my data logger category, and you can just watch me here for a second. You'll have time to do this yourselves, don't worry. And in here I have lots of different options, but one of them says set columns. So if I think about it, I want to make sure that I'm going to have a nice little table for myself, because I want to monitor how many particles are we keeping and how many did we have to skip, because that might be useful for us to know as well as we keep conducting different investigations. So I'm going to click on set columns. Is that okay, Mariana? Yeah. I'm going to take this one out here in a minute. I'm just going to drop it here. But before we begin, can I just ask you, how often do we have to do this? Like, is this going to just happen once? So the microbit on start here might mean like it just happens initially, or is this something in our LHC that is happening all the time?
So, you know, the LHC is not running forever,
yeah.
But when it's running for weeks, months in a row, it's a bit like as it is in running forever because it's happening all the time.
Over and over and over.
Yes.
Okay, perfect. So in that case, folks, I'm going to get rid of my on start over here. I'm going to bring my forever block in nice and central here for me to use. And let's take that first block that we brought out for set columns and we pop that in here. Okay, and Mariana, what do you think? I think there's two things really we're monitoring, isn't that what we said? So I might hit the plus sign because right now I only have the option to do one. So I'm going to hit this little plus sign. And can we name maybe the two things? What do you think we should call them?
So we will need two columns and we will need one to keep because, you know, it might be a new particle, a rare particle that we want to study further. Yeah. And we will need a skip column where, you know, it's a known particle. It's something that it's not that interesting for us to keep and study.
Okay, lovely. So I'm going to call them, you could just call them keep and skip if you want. I'm going to just say keep, little dash like that's new, and then skip, that's known. Okay, perfect. So that's going to be our columns in our table for our data. And you might notice what popped up. It popped up, it looks like it's behind us. So I'll just let you see it nice and clear here. Is this thing now that says show data. So because I'm using a block from that category, straight away it's letting me do that. And if I click it, right now there's nothing there. But in a little while, we will be making sure we actually log bits of information to a table that will be sitting in there when we click. So that's going to be really, really useful for us in our experiment as we go. So hopefully everyone's good. They have that. So remember we were using our forever block. Just to recap, we were going into data logger and we were going to set columns. We brought that out and we just made sure we have two columns that we're calling keep and skip. Okay, perfect. So that's that. Now, if you notice, I'm going to just hop back into the data logger for a second. There is a way to timestamp it. So because you said it's happening over and over and over again. Sometimes we might want to monitor the timing of different occurrences, like the keeping and the skipping, because you never know. Maybe there's something interesting to be found with that as well. To begin with, we might not use it, but I am going to get the block. So I'm going to encourage everyone to get this because we might use it in part 2 of our activity. So it might come in useful. So there is a block here called set timestamp. So I'm going to grab that block and I'm going to bring that in and I'm going to put that underneath. It's my next block in sequence of my code. And it is on none at the moment. And I think, Mariana, we're happy to leave it at that for the moment, aren't we? We might come back to it
exactly.
later on. Yeah. So I'm going to put that block there, set timestamp none. I'm going to leave that there. And before we give it a pause and make sure everyone's good with the code, we're just going to do maybe one more thing. So, Mariana, You were telling me earlier, we were chatting about this, and again, mind blown by all of this, that there are billions of collisions or just billions of new things you could be looking for, basically.
Yeah.
Yeah. So we can't obviously deal with billions right now. So we're going to think about a potential range. Do you think that would work?
Yeah, I would say maybe we could work with 6 particles that we want to look into.
Okay, so we're going to say there's 6 particles we're looking into, and probably 3 of them we're going to know about, and maybe 3 of them are the 3 things we're looking for that are new. Okay, perfect. So let's remember what Marianne said, that's 6. We also know that this is random. Like, we don't remember, this is why CERN exists. They have to keep running these experiments because they don't know what's going to happen. And that's what's exciting about it, I suppose. So this is going to be random. So that whether it's 1, 2, 3, 4, 5, or 6, the particle that comes out of this collision, we're not going to know which one it is. It's going to be completely random. So to do this and to mimic this, everyone, we are going to have to create something called a variable. Okay, so I'm going to click on the variable category, and in here you can see it's empty, because variables are things that we create in our computer programs, and we get them then to store certain types of information as different things occur in the program. So I am going to click on that, and I'm going to click on make a variable, and you can do this with me as well. I'm going to call that variable collision. I always spell this wrong, is that right? Or is it 1S? That looks better. Okay, so I'm just guessing, but anyway, we know what we mean. So I'm going to go with that as my variable name. So this is going to be the collision. And then from the collision, we can have 1, 2, 3, 4, 5, or 6 that might happen, basically, in terms of a particle. Particle 1, particle 2, particle 3, etc. Okay? So I'm going to say collision. I'm going to click OK. Happy with that?
Yeah.
So we have 3 blocks here. So hopefully you're still with me. And on the screen with those 3 blocks, there's different options. There's set the collision, the variable, to be something here. At the moment, it's saying 0. There's the option to change that variable. And then there's the option just to use that variable on its own, which might come in useful later on, where we might need to kind of reuse that variable within our program at different points. So I am going to decide that we're going to use this one first, so everyone can do this with me. We are going to say set the collision to be. So we're going to grab this block, and we're going to bring it out, and we're going to pop it in here. And remember, everyone, I'll give you a moment. Don't worry. We will take a pause after this last little bit I'm going to do. Just make sure everyone is good. So right now it's saying 0, Mariana, which is not what we said. We said that after a collision, there could be 6 different particles that occur, and they are going to be random. So there's kind of 2 things we need to think about there. Now, if everybody looks at the categories in my microbit menu over here, and you think about it, where do you think we could find something to do with random numbers? Random numbers. Okay, what do you think, Mariana?
I would say probably in math.
Math category, yeah. And I'm going to go down here into math. And in the math category, I have a little roundy block right here that says pick random 0 to 10. So that's exactly what we were talking about. That's what we want to try and mimic and simulate here within our environment. So I'm going to get that roundy block from my math menu that says pick random 0 to 10. I'm going to bring it out. And if you look carefully, I'm going to let it pop here. So you'll see there's like a little connector. It's trying to help me, trying to make sure I know where to place it. So I'm going to let that pop in there. And Mariana, you said we're looking for, there could be how many? 6.
From 1 to 6.
From 1 to 6. Perfect. 1, 2, 6. Okay. So there could be particle 1, particle 2, particle 3, particle 4, particle 5, particle 6, yes, basically. And we don't know, the beauty of this is that variable, we don't know which one has happened, okay? And in a minute, we'll decide what happens next. But for the moment, I'm just going to pause there because I just want to make sure everyone's good. If you got that far, you might be starting to think ahead. Okay, what could we do to monitor or get our program to actually log this? Okay, so you could think ahead a little bit. But for the moment, just make sure we get to here. We're going to bring you through the rest in a minute's time. Okay, so if we just think about our code for a second, nothing's happening on the microbit screen right now, right? So what we're seeing is we've told already the data simulator, you get ready to log this data, have this table ready for us. We've also told the microbit that all the time, this variable is going to be storing a random number between 1 and 6, which kind of represents our 6 different particles that might happen. Now, Mariana, we might just decide on a range of numbers that we think are going to be our new, exciting particles, the ones we want to keep. So what do you think? What range of numbers shall we assign as our keep?
I would say above 3. So particle 4, 5, and 6, they can be rare particles that we are interested in.
Okay, lovely. So 4, 5, and 6, we're going to say keep, and we might actually decide on some sort of a visual on our microbit screen to let us know, like, this is something you want to keep, because we do need to keep track of this ourselves.
Yeah, exactly.
We need to log this information too. Okay, lovely. And then, so that means if we're saying over 3 is keep, then everything else is skip.
Yeah.
Like if it's not over 3, then it's going to be,
we already know.
we know about it. So basically particles 1, 2, and 3 are things we know about. We're not as interested in them. So we're going to skip them. Okay, perfect. Now, to get the microbit to do this, we need to allow it to make that decision. It has to have this decision-making capability. And for that to happen, we use conditional statements, which I mentioned back when we were looking at our slides. And they sit within our logic category. So you can see here in our logic category, up the very top, or there's 2 blocks. We're actually going to use this one today. The second block down, it says if true, then or else. So that's the block that we are going to use in this case. So we're going to grab this one and we're going to bring this out and make sure it's the next sequence in our code. If it jumped in on top of this, it wouldn't actually make sense. So we need to make sure our sequencing stays correct when we're coding as we go. And so we're saying if something then. So Mariana, you just said there basically if whatever number is stored by our collision variable is greater than 3, then we are going to say keep. Now, while I do the code, I want you to start thinking about a visual you want on the screen maybe, okay? So hopefully everyone has this block in here now. The next block we're going to go and find is in our logic category as well. And that's what allows us to compare things. So we want to compare if this collision variable is storing a number greater than 3. So if I go in here and I go down in my little comparison area here, there is these blocks that allow us to do that very thing, okay? I'm going to grab the very first one here and I'm going to bring it out, and it's like a sideways diamond shape, you might notice. And straight away it's trying to go to it's like a jigsaw. It knows it fits there. So it's going to want to go into where the word true was. You're going to put that sideways diamond. And for the moment, it doesn't make sense, but that's okay because we're going to fix it. And it just says 0 equals 0. Okay, but we'll fix that in a moment. Just make sure that you get it from here, you pop it in here, and now we can add in the rest. So Mariana, help me out here. We want to say if what the variables, our variable was called.
So if a collision.
The collision, yeah. So I'm going to go into variables, and that little roundy that I mentioned earlier that we might need again to pop in, this is exactly when we need it. We're going to grab that one, we're going to bring it out, and we're going to pop it into the very first area. So if collision. And we're not actually seeing, does it equal a number, aren't we not? We want to see if it's above, greater than. So I'm going to click my little arrow beside my equal sign. Arrows in MakeCode mean I have options, which is really nice. So I can see all my options now. And we make sure that we go and we get the correct symbol for greater than, which is this one. And we click on that there. So hopefully everyone's with me so far. And as Mariana said, we are going to say greater than 3, which what that means out of this range of numbers is it's 4, 5, and 6. That's the only possible number they've picked greater than 3. All good so far?
Yeah.
Okay, hopefully everyone's still with me. So Mariana, I want, when this happens, if the collision, if the number stored here is greater than 3, I want to see something, I think, on my screen. We are going to log it. We'll get to that in a minute, but I also think I want a visual. So I am going to go into my basic category. And I think we might find something in our icons area.
Yeah.
Is that okay? So I'm going to get this nice blue block here that says show icon. I'm going to pop that into my first area. And Mariana, you have a little look here. I'm going to click the arrow. Is there any, I'm going to, loads of little options here. I'll slowly scroll down for you to get a good view. Okay. Choice is yours, Mariana. Which one would you like?
Bottom left.
Bottom left. This one?
Yeah.
Okay, the diamond. Okay, love it. So when we see a diamond, everybody, now in a minute, that will mean that that's something, that's a new particle. We want to keep it.
Yeah.
It means it was particle 4, 5, or 6. We want to keep it. Okay, great. Lovely. Now, I also want to make sure this is, if we remind everyone, this is happening forever. So if it stores the number 4, 5, or 6, it's going to show us this, and it's going to start repeating itself really quickly. And it might be actually hard for us to know how many times. So we're going to do a little hack here so that we just give ourselves a bit of a breather so that we know something is like that something has happened maybe more than once in sequence. So I'm going to go into basic. And I'm actually going to get a blank lights. This basically will turn all the lights off. So I'll see a diamond, but then I want to turn the lights off so that if the diamond comes back again, I know it's come back. Otherwise, it might just look like the diamond is sitting there forever and I won't know how many times. Do you know what I mean? So I'm going to get this show LEDs block and I'm going to pop that in to here. Okay, perfect. Great stuff, folks. So I'm going to pause again there just for a minute, just to make sure everyone is good to go. You can obviously pick whatever symbol you want, by the way, or any icon. It's up to you to decide on your icon. But you just need to know that whatever this icon is, that's your keep. That's your new rare particle that you want to keep investigating. So just make sure of that. Add your blank show LEDs. Both of these were from the basic category. And then we'll move on to our final part with our else, so that to get the particle collision going. And we'll keep going from there. So another minute, just make sure we're all good. Let us know in the Q&A if you need anything explained again, and we'll get back to you then. Okay, folks, well done. Really good work. So you might notice actually our microbit is doing the flash now. So it's like keep. But obviously it's doing that because that's all it knows how to do. It doesn't have the ability to make any other decision than this one. So we need to now make sure we put something in else. And remember, if it's not greater than 3, it must be 1, 2, and 3. Which means that's the things we want to skip them. So we're just going to, Mariana, basically do the same thing again, except this time it's going to be a different icon. So I'm going to go down, show icon. I'll just zoom in a little bit to make sure everyone can see it. And maybe if you want to let me know, again, which ones we want to skip. Anything jumping out at you there?
It can be that left triangle where you have the...
This one?
Yeah, exactly.
Yeah, perfect. So that's going to be skip. Lovely. Okay, so I'm going to go with this one. That's going to be skip. And same thing as before, this might happen too quick for us to really monitor. So I'm going to get this nice blank LED block once more. And I'm going to bring that in here so that it actually flashes for me as well. So now you might notice when you have that done, and obviously we'll give everyone a second just to catch up. I'm just making sure you can see my code on the screen. You might notice over here on my simulator, Mariana, we're going back and forth. So it's random, which is what we said would happen, and it is always random. So it is a real life example of we don't know. But the key thing is we have that visual aid now to know, right, that's keep and that's skip and that's so on. Okay. Hopefully everyone's with me. We're going to do 2 more parts to this where we're going to bring our buttons in. After this, I'm going to pause, go full screen and make sure everyone is okay. So don't worry, just do try to stay with me. But if you get lost for a block behind, don't worry, we will be pausing to make sure that everyone catches up. So Mariana, now is the time to log this data. So it's all very well and good. We have this flashing, but I don't even know still to the moment how many things have flashed. So we want to log it. And initially, we want to think about, well, sometimes humans have to log data, don't they? So let's, as the human user, let's log it and let's use our microbit buttons to do that. And the buttons on the microbit are inputs. So I'm going to go and I'm going to grab my input into my input category. And in my input category, I have the button C-shaped block like this. I'm going to bring that out and I'm actually going to just pop it over here for a minute. I'm going to zoom in just so we can see what I'm going to do. So we'll zoom in here. So I'm going to have my on button A block here. So on button A, Mariana, do you want to make sure that on A we log it that's something we want to keep or something that we want to skip?
Something that we want to keep.
Something that we want to keep. Okay. And remember, in this case, folks, we are logging data. So where do you think about it? Which category do we use? Well, obviously there's literally one called data logger. So that's the one we are going to use. And in here, we are going to say log data. Yep. We're going to drag that out and we're going to pop that into our button A block. All good?
Yeah.
Yep. And we're going to say log data in the column. You said keep. Yep. And we're going to give that a value of 1. Happy enough?
Yeah.
Okay, great. So that's that one done. That's A. So every time we hit A, it's because we've seen the diamond for us. You guys remember, you might have picked different icons. So that's no problem. Whatever your icon is for keep, you're going to hit A for that. And then when we hit B, it might be our
skip.
Yeah, and our sideways exactly triangle. And that's going to be our skip. So I'm going to go into input again. You might notice that there is no B option, but there is a lovely little arrow for me. And remember, arrows bring options in MakeCode. So I'm going to bring that in. I'm going to select on the arrow. I'm going to change it to B. And same block again, back into my data logger, log data, bring that one out. And this time, obviously, skip.
Skip.
Yeah. And that's when we see our sideways triangle. Yeah. Do you want to give that a value of 0 or 1?
It can be a 1 again, and
A 1?
it will be divided in different columns. So
Yeah, and we can keep count then. So then, because it might be interesting to know how many you are skipping too in a given experiment. Yeah. Okay. Lovely. Okay, so I'm going to go just off screen here for a sec, just so we can see our completed code, because there is a lot going on here now, and hopefully everyone's good, and I will make sure this is up for you in a moment. But just before I give you a few minutes to make sure you're caught up, I'm actually going to test this with Mariana. So you can watch us if you want, you can take a breather, don't worry, you will get time, so you can stop for a second. So Mariana, are you ready?
yes.
Okay, I'm going to go into this category here that says show data simulator. And you can see it's saying values will be logged when the simulator sends data. Okay, I'm going to click this refresh. And when I click the refresh, it's going so fast. I'm actually nervous for how. Okay, you just say keep or skip and I'll go. Right, ready?
Yes.
Refresh, go.
Skip, 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 keep,
Keep.
skip,
Oh,
keep, 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 keep.
okay, we get the idea. And as you can see over here, we have a lovely table now. And if this was to keep running and we were monitoring it, we'd very quickly start to see, okay, this is exciting because look how many new particles we have and so on and so forth. Okay, perfect. Right. So we know it's working. That's the main thing with our code. We test it. We make sure it's working. Lovely. All right. I am going to leave this up on the screen. I'll zoom in a little bit more, but I don't want to go fully off. I want to make sure the complete code is there for you if you do need to reference it. So remember, it is within our forever block. I'll just go off that one a bit. We're going to go off screen. We're going to give everyone another 3 minutes just to make sure you're good. There's one little change we're going to make to the code then just to see if we can make it more efficient. And then we're done. Then your particle detectives is complete. So not long left to go. Well done, everyone, so far. And if there's any questions in the Q&A, let us know. 3 minutes or so just to make sure you're good to go. And start running those tests and working together to log it and see how you get on. Okay, folks, hopefully everyone's good. Do let us know if you need anything explained again, and you hopefully are able to click on your show data and run the simulation and see that table generating. Amazing. Now, one thing I will say, Mariana, is you tell me again, sorry, the numbers are mind-blowing to me. So tell me again, like, this would probably be impossible for a human to monitor, really, would it?
I mean, it was already hard for us to monitor it like this. So imagine if you have millions and millions of collisions happening in microseconds and you need to take this decision in microseconds. So it will be really impossible for someone to be manually doing this.
So we want to automatically log this. And there is a simple way I think we can do this. So if everyone just even looks at their code now and thinks about this, we have the block, we have the instruction to log. We know when there's a particle we want to keep. So maybe if we just bring all that together, this will be an automatic occurrence. Yeah?
Yeah.
So I'm going to come over here to my button A. Remember, that was my keep log data. So I'm going to get that block out of there. And I'm going to bring that into my condition so that it happens within here. So if the collision is greater than 3, which remember was our diamond, which was our keep, we're not only going to see the diamond and the blank, we're going to actually log that automatically. That's going to make your lives easier, I think.
A lot easier.
Yeah. Okay, perfect. And exactly the same for skip, we're just going to get that one and we're going to bring that down and we're going to pop that in here so that when it's the number 1, 2, and 3, if it's not greater than 3, it's anything else, then we're going to say skip and we're going to log that one automatically. So in fact, we don't even need our button blocks anymore. You can leave them there if you want. I'm just going to throw them into the bin, but you can leave them if you want. It doesn't actually make a difference. So now we should see that happening. And actually, I think this is when it would be cool because now it's automatic. I'd like just to see the timings, I think, Mariana.
Yeah, that would be interesting.
Will we maybe come back up to our timestamp block? We had turned that off earlier on. I'm actually going to turn this on and we might go to, will we say seconds?
Seconds.
Yeah, okay, seconds. So set the timestamp to seconds. We now are going to say it's going to pick the random number between 1 and 6. Random particle is going to occur. If that random particle is either 4, 5, and 6, it's greater than 3. We'll see the diamond, we'll log it, say keep it. And if it's not, we'll see the sideways triangle and it's going to do this automatically. So let's just check that this actually works and then I'll give you another chance to catch up. I'm going to click show data. I'm going to refresh to start again. Boom. Okay. So we have a keep, we've skip, skip, skip. You can see again, it's completely random. Oh, wow. Good few skips in a row there. Okay. Yeah. and we're actually getting track of time. And all this data sometimes, you know, is useful because it actually might show us something different or something new as well as it goes. So these are all interesting findings potentially if you're doing an experiment to have not just the log of keep and skip, but also the timing of it as well. Okay, it's working. Again, that's the main thing. That's what I wanted to check. So I'm going to go back and I'm going to it's going to be a little bit smaller again because we've just made this forever block basically, or forever loop much longer. I'm going to leave that on the screen and we're going to give everyone 3 minutes or so to finish that out. And also in those 3 minutes, if you did have any questions, now's the time to make sure you did get them in, because we're going to bring Rua back and we're going to just maybe get we might have time just to fit 2 or 3 final closing questions in before we wrap up our Science Week live stream. Okay, so we'll see you in 3 minutes. Okay, folks, welcome back. So hopefully everyone got on well with their MakeCode for Microwave projects there. Let us know how you got on, and we will be sharing links in the Q&A to both sets of projects, part 1 when we did it with the user input, and part 2 where it automatically happens. So if you do need to teachers reopen those projects just to reference maybe at another point, they will be there for you in the Q&A in a moment. But for the moment, speaking of the Q&A, there were some questions that we have the time to get to, which is great, just before we finish up bang on 12 o'clock. So Rua, the first one that came in actually was, we talked about the Big Bang earlier, and the question was, what is the Big Bang?
So the Big Bang theory is an idea about how the universe started. Everything was created, all of space and time and all the particles that are that then went on to create everything that's around us. So it's this idea that there was just this one moment where there was this sudden Big Bang.
Okay, really good. And one question also that came in, I'm going to throw this to you, Mariana, is what does CERN stand for?
So CERN stands for European Organization for Nuclear Research, but the original name is actually in French, and I'm really sorry for my French, but it stands for Conseil Européen pour la Recherche Nucléaire.
Oh, that sounded beautiful.
Yeah.
So I don't know. Yeah. Well done. Love it. I thought it was magnifique. Okay, brilliant. Another question that we got in from everyone was, how many collisions are happening?
Yeah, so the collisions are happening really, really fast. So as you saw, like, it was already quite difficult to track your collisions, but we have collisions happening 40 billion times per second. So really loads and loads of collisions every second. It's really amazing.
Unbelievable. Okay, brilliant. And then the final question I think we have time for, Mariana, is to understand basically, are people from all over the world based there, or, you know, how many people are there, I suppose, and how, I think the question was, where are they from, basically?
So the environment is really, really international. You have people from all over the world, and also not working just in physics. So it's a very international place, but also very multidisciplinary. So, you know, in the future, if you want to work at CERN, you don't really need to be just a physicist. You can be an engineer, a mathematician. For example, I work in the communication area, so no scientific background, but it's a place where everyone from multiple areas and from multiple places in the world get together to advance science.
Amazing. Yeah. So like, I love that it is international. So you probably learn lots about different cultures and things like that as well, which is really nice. Yeah. And hopefully there'll be lots more Irish maybe in the future as well.
Absolutely. And you do learn a lot about different cultures, hear a lot of different languages. And actually, just to give a sense of the size of CERN, like, there are about 18,000 people on site every day. So it's a really big organization.
There you go.
From all over the world. And a very big site, yeah.
Yeah.
And it's somewhere that now all Irish students can be a part of.
Yes, hopefully. And hopefully you learned loads from our amazing partners in CERN today. Thank you so much, Rua and Mariana, for coming. They flew all the way in, folks, so like, big deal. So really, really do appreciate it. So we're going to finish up now, everyone. We want to just make sure that to say, well done, congratulations, you've completed our Dreamspace Live Science Week challenges. So whether it was our unplugged challenges, our plugged challenges at the end, we'd encourage you to make sure you share your experience on social media. So, you know, there, and use the hashtag MSDreamspace. There's an example there, and the hashtag CERN openlab, so that we can all keep track of it and see how you got on in your classrooms. And hopefully it was enjoyable. Let us know what you thought in the Q&A, and we hope to see you again at our next Dreamspace Live. But for now, from all of us here in Microsoft Dreamspace, goodbye. And
Bye.
From CERN. Yeah.
Bye.
From all the way back in CERN, we're going to send them packing now. They're getting their flights. They say goodbye as well, and we'll chat to you again soon. Thanks, folks. Bye.
Bye.